All right, today we are going to learn about the double angle formulas and how to use them to find solutions for equations. So first off, the sine of 2a is 2 sine a cosine a. And this is our identity. And now to find out why that is, the sine of a plus a is the same as saying sine a cosine a plus uh, cosine a sine a. And the reason is because if this was a b, there would be a b here and here, but they're the same variable, so we just write them across. So if we combine these two, it'd be 2 sine a cosine a. And keep in mind that we do test you on some of these, proving some of um, these theorems. So make sure you know how to prove these double angle theorems properties. All right, cosine of 2a is another double angle property that looks like this. And we get it similarly to how we got the first one. We do cosine a plus a, which is cosine a cosine a minus sine a sine a. And that's just expanding using composite argument property. Now cosine times cosine is cosine squared. Sine times sine is sine squared. And we have our property. These are nice, easy, quick proofs. Now sine of or cosine of 2a, this is one identity, but there's a couple more because um, sine squared minus sine squared would be cosine squared minus 1. So um, by doing that, oh, I think we can just erase. That would be, um, I could write that as cosine squared minus 1. So now that would be 2 cosine squared minus 1 is the same as cosine of 2a. So that's another property for the cosine of 2a. And we can similarly do that for cosine. And what we would do is um, we would replace the cosine. So it would become 1 minus sine squared minus sine squared. So that would be 1 minus 2 sine squared a. So those are a couple different properties for cosine of 2a. All right. Now we're moving to the tangent double angle property. Tangent of 2a is 2 tan a over 1 minus tangent squared a. And we prove this similarly. A plus a is tangent of a plus tangent of a over 1 minus tangent times tangent. Tangent a times tangent, or plus tangent a is 2 times tangent of a. This would be 1 minus tangent squared a, and we're done with the problem. Now, we move on to half angle properties. These are all the half angle properties. Now, we're not going to go through and prove these. The proofs will not be on the test or anything, but these are all properties that we should know how to use. Oh, and I thought there would be another slide on that. Now, the half angle properties, if I, it depends on what angle we're dealing with. So on whether it's positive or negative. So if I have the cosine um, of 1/2 a and the angle is down here, we can take a guess and say this is maybe like 250 degrees. So if I take the half of that, that would be 125. And at 125, the cosine would be negative. So in that case, we just use the negative. If I take the half of the angle and the cosine would be positive, say if I had an angle like this, say this is 160, and if I took half of it, it would be 80. So then I would just use the positive portion of that. And similarly with these other two. And I'll explain that better as we move on to problems with it. Okay, now we get into solving equations using these. Now, Part of this is just like a matching problem. Where do we see this on our property sheet? And hopefully we remember that this is the same thing as cosine of 2a. So the cosine of 2a is equal to root 3 over 2. Now this becomes just like our previous chapter where we have root 3 over 2, that's a 3, root 3 over 2, and so this would be 30 degrees and 150 degrees. So 2a is equal to 30 plus 360k, and 2a is equal to 150 plus 360k. Now if I divide by 2 on both sides, a will be 15 plus 180k, and it would be 75 plus 180k. Now we just look for the values between 0 and 360, and a would be 15, 75. If I add 180, that would be 195. Add 75 to 180, that's going to be 255. And if I keep going, it would be out of our range. So that looks good. All right, let's keep going. Now, if I want to solve this, this thing inside, where the square root is 1/2 1 minus cosine, is that's going to be the sine of 1/2 a. So I write 2 sine of 1/2 a minus 1 is equal to 0. Now I add 1 and divide by 2 on both sides of the equation. So sine of 1/2 is equal to 1/2. And now to get rid of the sine, we know opposite over hypotenuse is 1 over 2, 1 over 2. So that's going to be a 30 and 150 again. So 1/2 a is going to equal to 30 plus 360k. 1/2 a is going to equal 150 plus 360k. Now if I multiply by 2 on both sides, I would have 60 plus 720k and 300 plus 720k. And, oh, I just saw that I made a big mistake. I was doing this too quick, and I didn't see that this was in radians. So let's go back and say that this is pi over 6 and 5 pi over 6. And so now, when I write these out, we'll do the same thing, just have to make it radian. So pi over 6 plus 2 pi k. If I multiply that by 2, that would be 2 6 or 1 pi over 3 plus pi k. And this would be 5 pi over 6 plus 2 pi k. And if I multiply by 2, it would be 10 6, which is 5 pi over 3 plus pi k. There are some k's on here. All right, so oh, and then if I'm not thinking correctly, that would actually be by 4 pi because I'm multiplying by 2. All right, hopefully my mistakes didn't confuse you too much, uh, but this is how it should be. So I have pi over 3, 5 pi over 3, and now when I add 4 pi to both those, it goes outside of my range, and I'm all done. All right, this one gets kind of tricky for people. You have to see where this exists on your paper. The problem is it doesn't exist exactly like that. It exists 2 sine theta cosine theta. So we have to separate out 2 times that, which is 2 times the sine of 2 theta. So now what I have to do is divide both sides by 2, so sine of 2 theta is equal to negative root 2 over 2. And now I know sine is going to be negative down here and here. And the two triangles where it's negative is going to be over here at 225 and over here at 315. So 2 theta is going to equal 225 plus 360k, and 2 theta is equal to 1 through 315 plus 360k. So if I divide both sides by 2, I'm going to get 112.5 plus 180k. And if I divide this by 2, I'm going to get 157.5. I should use a calculator. I think I'm right. Plus 180k. So now I'd have 112.5. Add 180 to that, and that would be 292.5. And then we have 157.5, add 180 to that, we get 337.5. All right, so you have your general and your more specific solution. So here it says show numerically that sine of 1/2 a is equal to this. So that what that means is we need to just think of some number. So let's do the sine of half of 100. So if I'll take out my calculator here in a second. All right, I brought up my calculator. And if I want to take the sine of half of 100, which is 50, I'll hit enter. And we know the sine of 50 is 0.766. Now let's do this. 1 minus cosine of that angle. So 1 minus cosine of our whole angle A, which is 100, is going to be some value. Now if I divide that by 2, I'll get 0.58. Now if I take the square root of that answer and hit enter, see how I get the same value, 0.7660. Now let's do it for a bigger value. Let's say if my A was 300. Or actually this would have to be, for sine it would have to, if I want to do something, let's do sine of 500. So if I take the sine of 500, half of that would be 250. So if I take the sine of 250, that would be negative 0.9396. And now let's do the same thing, where I do 1 minus cosine of 500. Enter. Multiply that times a half. And now we square root it. Now this one I have 0.9396, so it's not perfect. This one's a negative and that's a positive, where over here they were both positive. That's why we need this positive and negative out in front, because sometimes it's going to equal out, like it does here, and other times we're going to need to change the sign. And the problem is this will always yield a positive result, but the sign won't always be positive. So you have to think about the double angle. If I have 500, half of 500 is 250, which is down here, and the sign would be a negative over a positive, so it would be negative. So then we'd know when we're using the half angle formula that we'd have to use the negative value. All right, so use the double and half angle formulas to solve this algebraically. If we know the sine of A is negative 3/5, so sine of A is negative 3/5, and that's between 180 and 270. So sine of A is negative 3 over 5. Hopefully you know that this side, using special rights, is negative 4. It says, what's the sine of 1/2 A? Well, we know the formula for sine of 1/2 A is plus or minus the square root of 1/2 1 minus cosine of A? Well, the cosine of A here is negative 4 over 5. So 1/2 times 1 minus a negative 4 over 4/5. So that's going to be 1/2. So 1, this would be plus, if it's minus a negative. 1 and 4/5 is the same thing as 9/5. So now when I multiply them, that would be the square root of 1 times 9 is 9 over 10. So the square root of 9/10. Now we have to think, is this positive or negative? So if I take this value, we don't know what it is without a calculator, but let's just guess it's 250. If I take that in half and I have 125, which is up here, is the sign going to be positive or negative? Hopefully you're saying that the sign is going to be positive because it's opposite over hypotenuse and both those are positive values. So our answer here is just going to be 9/10. Excuse me. So now if I find the cosine of 2a, the cosine of 2a is cosine squared a minus sine squared a. So what we need to do is take cosine, which is negative 4/5, and we're going to square that, minus the sine, which is negative 3/5, and square that. So this becomes 16/25 minus 9/25. So that would just be 7/25. And that's our answer. Let's try another one like this. If we know the cosine of it is 5/13 between 270 and 360, we know 270 is down here, 360 is right here. The cosine is 5/13. Hopefully you know with your special rights, this set over here is 12, and we should throw a negative because it's going down. If it says sine of 2a, we know that this is 2 sine a cosine a. And the sine of a is going to be the opposite, which is negative 12 over hypotenuse, which is 13. And the cosine is going to be 5/13. So now when I multiply this across, it's going to be 10 times 12, which is negative 120, all over 169. All right, so now if I look at cosine of 1/2 a, that's going to be plus or minus the square root of 1/2 1 plus cosine of a. Well, cosine of a is pretty easy. That's going to be 5/13. So we have 1/2 1 plus 5/13. And 5/13 plus 1, that's like 13/13 plus that. So that's going to be 18/13. So this would be 18/26 that we're dealing with. And we could reduce that by 2 to be, what, 9/13. Now we have to decide if that's positive or negative. If we look at this value, let's say we don't know what it is, but let's guess it's 300. If it's 300 and we cut it in half, it would be some value over here, which would be 150-ish. And is the cosine positive or negative over here? Hopefully you're saying a negative because it's a negative over a positive. So this answer must have a negative value in front. And then we're done. All right, hopefully that's good enough to do your homework. Good luck.